In this first problem, what we want to do is determine if this function, it is a function, right? Because each one of the input values goes to exactly one output value. Now, we want to determine, is the function linear or not linear? So we'll explore two things. First of all, part A. Here's part A. Is the change in the x values the same? All right, so look at what we have for the x. We go from -3 to -2 to -1 to 0 to 1, 2, and 3. So it looks like the x's are increasing by 1 each time. So I'll write it here. So as you can see here, as you start at any x value, you increment it by 1 each time. Now, part B is down here. And part B is a change in the outputs, y the same. So look at the y's. Now, the y's, we're going from -10 to -7, up 3. -7 to -4, up 3. -4 to -1, up 3. -1 to 2, up 3, up 3, up 3. So it looks like the y's are increasing by 1. Now, if you want to see this for sure, take a look at what we're doing here. I'll start down here and then I'll go back. How do you get from 5 to 8? All right, so I'm going to take this. So you could always do something like this. 8 minus 5, right? I'm going to take 1, subtract the previous one. Now, 8 minus 5 is 3. Now go here. I just did this one to this one. Now do this one to the one above it. 5 minus 2. 5 minus 2. That's also 3. Now, do 2 minus -1. All right, so now I have the 2 minus -1, which is 2 plus 1, which is 3. And we'll do one more. -1 to -4. All right, so now I have -1 minus -4. Right, what I'm doing a minus because I want to know the difference between these two numbers. All right, so this becomes -1 plus 4, which is 3. So in part C, is the function linear? Yeah, as long as the x's are increasing by the same amount, making the y's increase by the same amount, then the function is linear. So we're going to say yes, this function is linear. Here's another function. Now this table does represent a function because every x goes to only one y, right? 11 goes only to 3.5, nothing else. 26 only to 5.1, nothing else, and so on. Now let's check to see if it's linear. So part A over here is, first of all, we're going to check the increments on the x's, the increments on the inputs. Now, I'll do this in step by step. So what about the increment from 11 to 26? All right, so we would compute that like this. What is 26 minus 11? It's 15. Now go to the next one. What is, all right, we just did 26 minus 11. Now jump up. What is 41 minus 26? That's 15. Then 56 minus 41. That's 15. Then 71 minus 56. That's 15. Then 86 minus 71. That's 15. And then finally, 101 minus 86. That's 15 also. So part A, we're going to answer yes, and it's equal to 15. Now we'll check the change in the y. So what are we going to do? We're going to do the same thing we did for the x's. I'm going to start here, 5.1 to 3.5, all right? From 3.5, what do we increment by to get to 5.1? So we are going to take, all right, these are the x's. These are the y's coming up. We'll take 5.1 minus 3.5. Now get your calculator if you like. I got 1.6. Now, the next one, right? We just did 5.1 minus 3.5. Now do 7.5 minus 5.1. Right? So 7.5 minus 5.1. Well, I got 2.4, and right away these are not equal. All right. So the y's are not increasing the same. So is the change in y, the output's the same? No. All right, so no. So if we increment x by the same amount, but then the increments in y's are different, then is the function linear? No, it is not linear. Let's find the slope of this line. Now, this is a horizontal line, and I'm sure it's horizontal because in this point here, I'm down, what? I'm down 5, and in this point here, I'm down 5. It's a horizontal line, and I know that the slope, I'm going to write it here, the slope of a horizontal line is 0. Now, if you want to compute, we can compute also. So you use the slope formula. Slope formula says it's a fraction. Take the second y minus the first y over the second x minus the first x. Now, as I look at these 2 points, I just go from left to right. Just go left to right. The first point I see is this one. All right, so I'm going to say this. That's the first x I see, and that is the first y I see. Then as I keep moving left to right, that is the second x that I see, and that is the second y that I see. So I'm just going to substitute these values here into my formula down here. So let's do that. So we'll get the slope being the second y. Now the second y is a -5 minus the first y. But the first y is also a -5, right? So we have -5 minus -5 over, now the second x, that's the second x, which is a 2, minus the first x. And the first x is this one right here, -5. Careful with the parentheses. Right, so the slope is going to be -5 plus 5 over 2 plus 5. So we're going to get the slope is 0 over 7. But 0 divided by a non-zero number is 0. All right, so it works when we compute it, but you also will want to know that the slope of a horizontal line is 0. Let's get the slope of the line that passes through these 2 points. Now, as I look left to right, well, first of all, when I want to find the slope, the first thing I'm going to do is write my formula, right? So the slope formula is, it's a fraction, second y minus first y. The difference in the y values, that's a vertical difference because the y values go up and down. So I take the second y minus the first y, so I get this vertical distance, divided by second x minus first x. Now the x's are horizontal, so I'm going to take the second x minus the first x. That's going to give me the horizontal distance. So let's identify here. Now as I look left to right at these points, this point is the first x that I see. This is the first y that I see. This is the second x that I see. This is the second y that I see. So I'm going to substitute these values here into my formula down here. So the slope is, all right, second y, which is 6, minus, right, there's the minus sign, the first y. And the first y is -10. Over second x, now the second x is a 6, minus, all right, there's the minus the first x. Now the first x is a 2. All right, so let's put in the 2. All right, so now just simplify. We're going to get 6 plus 10 over 4. The slope is going to be 16 over 4. So the slope is 4. We've got it. Now, just so we know what it means, if you imagine you're on this line, right? Here's 2 points, pass a line through them. Now, if you're anywhere on that line, if you're anywhere on the line, say that point is on the line. If you start at that point and increase by 1, right, this is really 4 over 1, to get back to the line, you would have to go up 4, right? Does that make sense? Look at the bottom number. I always like the bottom number first. That tells you how to change the horizontal. So I start at this point. This says change the horizontal by 1 unit. That tells me that's the y's. That's a change in the y, right? Change, minus. All right, so if I increase x by 1, positive 1, I'm going to have to increase y by 4. So start at any point on the line. If you increase x by 1, increase the horizontal by 1, the vertical will increase by 4, and then I will be back on the line. Let's find the slope of the line that passes through these 2 points here. Over 2, down 5, and then over 2, down 9. You know what? If we just get kind of a picture of this, here's what we're going to do. Here's the origin. We're going to go over 2 and then down 5. Then we're going to go over 2 and down 9. I think we're going to get a vertical line, and the slope of the vertical line is undefined. Let's compute and make sure that it works. All right, so the slope formula is second y minus first y over second x minus first x. Now, let's identify here. Here's the first x, there's the first y. Here's the second x, here's the second y. So, on the top, second y minus first y. Second y is negative 9 minus the first y, negative 5. So the slope is going to be second y, negative 9, minus first y, negative 5, over second x, right? Second x minus first x. Second x is 2 minus the first x, which is 2. Oh, I can see it now. All right, so the slope is negative 9 plus 5 all over 0, and it doesn't matter what that top is. Well, it's not 0, so the slope is negative 4 over 0. And if you have a non-negative number, if you have a non-zero divided by 0, then this is undefined. Right? So this slope is undefined because it's a vertical line. In problem 6, we are going to find the slope, if it exists, of a line containing this pair of points. 5, 1, you know what, I think I'm going to graph it. It doesn't ask us to, but I'd just like to get a picture of it. 1, here's where I am. 1, 2, 3, 4, 5, and up 1. So right there, let's put a point right there at 5 and 1. Okay, I'm over 5, up 1. Now, what's the second point? The second point is to the left 7, up 1. All right, so to the left 7, so I'm going to start at the origin. To the left 7 puts me here and up 1. Oh, I see it. Right there. Now, look, in each case, I went up 1. I went up 1 unit. So when I draw that line, it's going to be horizontal. So without any computations at all, I know that the slope is 0. Now, if you insist on doing this, m equals y2 minus y1 over x2 minus x1, here's what we get. Second y, 1, minus the first y, right? Second y minus the first y. You get 1 minus 1. Right away, you know you're going to get 0 in the top. And what about the bottom? Second x minus the first x. So this is going to be negative 7 minus 1. So you get 0 over negative 8. Now 0 divided by a non-zero number is 0. Let's find the slope of the line containing these 2 points. Now we've got fractions. Let's not worry about it. Look at the denominators. 8, 2, and 4. They all seem to have a 2 in common. We might be okay here when we have to subtract. So I want to find the slope, so I'll start with the slope formula. M is equal to y2 minus y1 over x2 minus x1. So the slope is, okay, second y minus first y. All right, so second y is 1/4 minus the first y, which is negative 1/2, over second x. Now the second x is 1/4 minus the first x, 7/8. Now I can fix the top up a little bit. How about this? M is equal to 1/4 plus 1/2 all over 1/4 minus 7/8. Right, now let me show you a little trick. This always works, and I'll prove that it works. Here's what I'm going to do. Now, this is going to make it look longer than it really is, but what is the least common multiple of these numbers? In other words, what is the smallest number that all four of these denominators divide into? Called it LCM, least common multiple. The smallest number that these four divide into is 8. All right, so I'll write that here. The LCM is 8. Now, here's what I'm going to do. I'm going to write 1, okay? Write 1 as 8 over 8. Okay, that 8's coming from here. Now, here's why I do that. I'm going to do it up here. M is equal to 1/4 plus 1/2 over 1/4 minus 7/8. Now, if I multiply that by 1, it's the same, right? If you multiply by 1, it doesn't change the value. But the one I'm going to choose, I'm going to choose to write 1 this way. So I'll erase that one, and I'll write it as 8 over 8. And now it looks like this. The slope is equal to 1/4 plus 1/2 times 8 over 1/4 minus 7/8 times 8. And now what do? You multiply the 8 in, you multiply the 8 in. So you get this. 1/4 times 8 plus 1/2 times 8 over 1/4 times 8 minus 7/8 times 8. Now, all of this stuff here, you're not going to be writing. You're going to get to this point right here. You're going to get the LCM, and then what happens with the LCM? Forget all this. The LCM does what? The LCM just multiplies. Here's the LCM. You multiply it here, 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 and here. So just get the LCM, multiply every one of the originals by the LCM. Now it works because of all this, but we're surely not going to write all that. Now when you do this, all the denominators cancel out. That's what's the nice thing about doing this. 4 will go into 8 twice, giving 1 times 2, which is 2. I'll do it up here. So m is equal to 2, and then plus what happens here. 2 into 8 is 4, so 1 times 4 is 4. 2 plus 4. And in the bottom, 4 will go into 8 twice, so I get 1 times 2, which is 2, minus, right, minus because of that minus right there. Okay. Now, 8 into 8 is once. 7 times 1 is 7. Okay, let me make them all the same color here. M is equal to 2 plus 4 is 6 over negative 5. Now, I'm going to put the negative sign either out in front or on the top. You could write it negative 6 over 5, or, this is the way I like to do it, I put a negative 6 over 5. All right, but they're all three the same. We've got another slope problem. Now find the slope of the line containing the given points. F of 1 is 10. All right, now that means when the x value is 1, the function converts the 1 to a 10. All right, so I actually have this ordered pair right here. This is really an x and a y, and I have 1 and 10, right? F, this function f, whatever it is, converts a 1 into a 10. And then what have we got over here? F of 7 is 4, all right? That's this ordered pair. Put in a 7, get out a negative 4. Okay, so here's my 2 points. There's the x1, the y1, the x2, and the y2. Here's our slope formula. y2 minus y1 over x2 minus x1. The slope is, right, second y minus first y. Okay, up here. Second y is negative 4. First y is 10. So negative 4 minus 10. Bottom. Second x, which is 7, right? Second x is 7. First x is a 1. Oh, get it to right. All right, so what do we get here? M is equal to negative 14 over 6. We can reduce. M is equal to 2 will divide each one of those, so I'll get negative 7 over 3. Now, here's what this means, right? It's good to know what it means. This is the slope. Now, if you imagine yourself anywhere on the line, okay, anywhere on the line, The bottom number is the change in x. It's the change in x because change in x, look at the formula. If you have the difference between two numbers, it tells you how much one changes. Right? If you take your age 5 years from now, you take your 5 year from now age minus this age. That's the change. So it's the change in x. Now that's the horizontal. This is the horizontal. That's the change in the horizontal. So we're going to change the horizontal by 3. So you go over 3. Then the top number, well, look at the top. Now, the top number comes from the change in y's. This is how the y's, now the y's are the vertical, okay? The top number, this is the change in y, and that's the vertical change, okay? So our vertical change is what? Down 7. Down because of the minus. All right, so not minus, a negative. So I'm going to go down 7. All right, so I go down 7. I'm not going to put a negative there. I know I'm going down. I'm going to the right 3, down 7. All right? Now, if I draw a line, so if I start at any point on the line, I go to the right 3 and down 7, I'll be back on the line.